What we saw in the last video is that a semi-definite program is a linear program in just a particular case of a semi-definite program where you cannot have um, the semi-definite positive matrices. That the original form of it is just this for semi-definite programming. And so today I want to go with you with an example. As I told you, this is just the general form, but you can encounter SDPs which are not in this form. And for example, this is an SDP, and it's really hard. Not hard, but really tedious, I would say. A lot of calculation for nothing, from going from a form which is not the general form to the general form. And so maybe we'll do it in the video, but if you have exams or some tests, normally they will not try to tell you, please do me this unuseful calculation, because that's not really funny to do. Maybe we'll do on some, but if you have exam or some stuff, I do not think that your professor will give it to you. Even if maybe he can. But yeah. Anyways, this is a real SDP, because we have also complex SDP with complex numbers. So yeah, we know. So what we'll try to do here, it just like as we did for linear programming, we find a way to solve it, and thanks to the equations. So as you know, the main equations are just two ones, and so the fact is you just need to to solve this. You just take the determinant superior to zero in a way, like y minus AD minus BC. So it's y minus BC. It's y minus x squared superior to zero, and so it's y superior to x squared. Same here for x minus x plus y superior to x plus y squared superior to zero. So you have it like this. And so you have your two equations. You can put them in some stuff. And so if you put them in a can calculate, with graphical calculation, you'll find something like this. It's really approximative as a graph, but and so yeah, you have, so this one is y is equal x squared. So that's the first equation. And this one, all of here, it just x plus y squared equal 4x. And so as we did in linear programming, I recommend you watching the graphical solution of linear programming. You'll maybe understand better. For maybe if you understand already here, it's okay. But so here, what you have is just, so you see your point is here, And so you'll see like if you use your, maybe you can do it by hand, but I use graphical stuff that can calculate the curves. So you see is one. So if you trace the curve of it, like it's something that's normal like this, that represents your stuff here, which is x plus y equal to. So typically here y equal 0 and x equal 2. So this point is 2, 0. And so this point here will be 0, 0, 2. But yeah, just graphically you can solve it. And so just wanted to say you that this is just a form, like you can transform it into this, even if it's not really, I mean, just calculation, but it takes times for doing it. Or you're really good for doing calculation in comparison of the population in general. And so yeah, just and you can solve it to resolve problems and makes money with it as Google make, thanks to optimization, and here is convex optimization.